Hello and welcome back. Once again, this is Becca going by Nightcat or Nightcat's Meow when online. And welcome to another video on the topic of Linden scripting language and pretty much anything to do with creativity in the virtual wildlands of Second Life. We have a specific question this week from a Karen W regarding trouble with mesh and its physics. And she says that it worked fine in the main, actually Linden viewer for SL, but not in Firestorm. As a avid fan of Firestorm myself, I can definitely understand that being a hindrance. Unfortunately, I'm not quite as experienced with mesh as I am with scripting. Most of my experiments have just been for work on altering existing openly available, like free for any non-commercial use kind of thing, 3D models to build stuff for friends. But I have learned a few things from that. I'm going to go over the different things related to physics and what they may mean, and hopefully somewhere in there it will point out something that might help you. Though, since once the model is uploaded, its physics is pretty well baked in, so it's most likely going to be a matter of one of the physics settings in the item properties, I would guess. But again, I'm a lot less of an expert on mesh and physics than I am coding. But to walk through the actual mesh upload, this is actually for a custom transformer I was putting together for a friend. We're going to skip to when it's finished scanning the model and ready to go. Okay, and here we go. I'm gonna put that down there. Okay, here we go. We're back. And as you see, this is basically just a particularly fancy little pickup truck here. Probably just insulted any car nerds that know far more about this than I do, but it was for a custom transformer model. So they found a truck they really liked in SL. This is the closest model I could find out of SL, and they needed some parts for her transformed version. That's the short and sweet of it. But you see the different level of detail settings. These affect largely what the model looks like at range. The further away you get, you'll see different degrees of detail. That one looks a little less crisp, a little more funky, and really kind of janked up here. These are important because you can set those in the physics. You can set any one of those as the physics. Level of detail basically is how much mesh detail there is, basically how many triangles and points and all of that the mesh is made up from. But you do have an extra option from file. You can actually do that for any of them. So if you wanted to, I think some of the real master mesh builders use that to make things that still look good no matter the range, but have a very low upload cost and land impact because the complexity of the model denotes its overall equivalent in frame count. But if you didn't really mess with any of those, then I'm guessing it's going to be something else. So I will give you an example just so that we've covered all the bases of what I think is an example of from file on something that is here on my sim. But the other options that I refer to, if we pop out here, I actually covered these in the first sit teleport video, but it's worth reviewing. We have a mesh piece of building right here. And under features, it has physics type print. This attempts to roughly match its physics to the, it is whatever level of detail you set in the upload for the object is what is going to show up under physics type prim. Convex hull just roughly tries to equate its physics shape to its length, width, and breadth, but it doesn't really pay much attention to the contours that are actually made into it. And then there's none. The best guess I've got, since the settings should be pretty consistent once they're loaded, is it's probably something in there. So, that said, let's look at some of the things that can an example of something that I think is loaded from a custom mesh file. We'll also discuss briefly the avatar physics, and hopefully, again, somewhere in there, something in this will have given you what you need to answer the question. The first thing to consider is if you're talking about how the physics interacts with an avatar, you need to understand that the avatar is not going, what you look at when you look at these pretty avatars is not what SL processes, not really. So we're going to go avatar hitbox and under metadata collision skeletons. There we go. Actually, that one inside is probably the more important one. Is these represent the actual structure of the avatar as far as Second Life is concerned. The hitbox is going to handle anything involving physics collision. You see that purple box around there. As far as Second Life is concerned, that's me. That's where I'm standing. The skeleton you see inside is, if anything has to process a more precise version, that is its rough sketch of the actual skeleton of my avatar, as far as SL is concerned. Metadata collision skeletons. So if I were to go over to this curb, you'll notice I don't actually move. It moves me up, but not until the hitbox touches. My box can't enter this wall. But if I just stay here for a moment, my animation may very well try to move into it. Because my animation would be allowed to, because the avatar itself, everything you have attached to it, it doesn't really have any physical structure whatsoever. It's not really there. All that is there is this little, in terms of things that can hit and touch and interact, is this simplified box. This is done to cut down on the processing time as the actual world tries to decide how different things are going to interact. If it had to actually calculate my jacket and jeans and head and all these other shapes, it would be a much more complicated, much more time-consuming, and much more resource-intensive procedure. But most of the time, processing by this box, you don't notice the difference. It's one of those good enough to fake it kind of things. The other factor is everything around me. So, physics shape. Now, you saw before how my street, it actually had the full curve there, but here you just see two flat planes. Because for most cases, since my bounding box, the box that dictates my avatar's physics shape, is larger than the hole here, I just kind of get moved up and out of the way. But if I were to create a box, just a basic box, the Mark I cube, turn off physics shapes, and I make it physical, I can now drag it around by a click here, is it tries to begin to interact there as it tips over that. It doesn't really know what to think of things there. If I go to set it down from up here, there it impacts. Where it is solid. Over there, it impacts. Where it is solid. It has a bit of trouble here because part of this, it wants to kind of slide through, but then it has an actual physics plane up here. If I bring that down to where it is below the physics plane, it just slides right through there with nothing. It is possible whatever you were dealing with in terms of physics, if it had a special level of detail file uploaded to define its physics, then that may be what you're running into, and it may be variable based on how the avatar hitbox touches that. And the way you can investigate these is you get the developer console window open, render metadata, then you have avatar hitboxes, and you have physics shapes. Those can help you figure out a lot of this. I actually used those a lot when I was trying to get these roads lined up so that I could, because I had some trouble with them at first. I did not make these roads, by the way. I bought them. But that is, I think, all I can do without a lot more detail and a lot more poking at your particular model and issues. But today's real course is to finish the third and final on our series on SIT teleports, or SIM teleports, really. I'm going to show you a variable destination teleport, which is good for making an elevator system, and I'm going to show you a map-based teleport system. This is another way of being able to teleport anywhere in a given sim, and sometimes even to a different sim if you need to connect different ones. If you have a case where you have a Here we are at the police station for my sim. It is a cyberpunk sim. Of course, there have to be cops. Despite the fact that I'm walking around as the cat girl, by the way, this is really meant as a closer to a sci-fi version of our world. The full feline thing doesn't necessarily fit the sim, but you know, that's neither here nor there. Anyway, this is a special variation on my SIT teleport. When I click on it, it drops down a menu. It'll start with the lockup. It opens up. I sit on it. And it drops me down here in the actual police station lockup. I take it back up. Choose again. Offices. Sit here. And it sends me up to the offices. So this is very good for an elevator system inside a sim, but you're probably wondering, how exactly is this put together? Well, let me show you. There's only a few things that are really different from what you're already used to. We'll start out in the state entry. I have the sit target and the set region position. That one is basically just, it made it easy to recover when I was developing it and making sure it worked. The target position none is established up here, and that's going to be the same as the default it goes to whenever it's restarted. You notice I have pre-established as global variables, which means they're accessible anywhere in the entire script, several possible destinations. They have their name, their type, vector, their name, in this case C-swap, equals, and then a vector, which in this case is a position in three-dimensional space. If you sit on it, this gets a little bit more complicated by a couple of things, so we're going to come back to this, though the main function of it works exactly the same as the SIT teleports I've taught you before. If this is your first video of mine, I will have a link in the description to 2 videos ago where I actually first talked about SIT teleports, because that will teach you an awful lot about them. It'll teach you everything about this that this video won't. Where this one gets interesting is if you choose touch start. The very first thing it does is it detects your key. Who equals detected key 0. Who isn't defined as what type it is down there. That's because it's a global variable up here because it has to be accessible in more than one function. So it's established as a key. So when you touch it, it automatically goes, well, who is this? And records your key. We keep that by setting who to detected key 0. Otherwise, it would only stay inside this function. It then creates a dialog. And that's what you saw in that drop-down menu. That was a dialog box. Dialog, who, that tells it which key to bring up the dialog box for. Choose your floor, which we look right here. It says, my object, I really should change that to choose your floor, and it lists the different options. It has this variable here, floors, which is again defined up here as a global. List floors equals, and as we covered in the last week's video about security, all lists have to be contained inside these brackets, and then each item on the list is separated with a comma. So this gives a list of the buttons that we can put for selection here in the dropdown. You can get 9 of them up there at a time. I think it's 9, it might be 12, but you can get 9 of them up there at a time. Beyond that, you would use a next or a previous to go back and forth between separate lists, because there is that limit on how many of them you can show at one time. But we're nowhere near that point, so we don't really need to worry about that here. And then it lists 99. That's a key. The thing is, anytime you select one of these, it's actually as though you are speaking it, you yourself. Let me set up a demonstration. We'll just put a simple listen in here. Listen. Did I set that as regular 99 or negative 99? I actually just suddenly forgot. Negative 99. Negative 99. Okay. Don't mind that, this is just me quickly establishing a listen. I've covered these in past videos, but basically it's the LL listen command, what channel you're listening to, what object name you're listening for, really useful if you're trying to filter for a given HUD or other device. We actually covered that in security when we set up the token. What key you're listening for if you want to filter, and what message you're looking for if you want to filter. And then it has to have the variables integer channel. You can call these whatever you want, but it's easiest to label them based on what they are. The integer channel, the string what, the name of whatever the object or person talking is, key who, whatever the key is, and string message. In this case, all we're really going to do is just repeat what is heard on channel 0. So say on channel 0, message. Save. So you see, the relay object picked up offices. Let's make that a little easier to keep track of. Sit here. Takes us to the offices. And these are all in the same building. These all occupy the correct space that they should be occupying. So we're going to move the physics box. We covered this where I talked about the usefulness of sit teleports before. And then just make this transparent for a moment. Now you can see, there I am, right there. Inside the actual building. Down here is the barracks floor that was mentioned in the thing there. And if I go underneath, we see the lockup. Put my building back together. So I've got the relay object here. We click on this. Lockup. Relay picked up lockup. Door opens. Sit. Boom, down we go. Don't mind that brief physics trouble. So when it speaks that on 99, or more accurately, you choose the button and your avatar speaks that on channel 99. Once the as the dialogue comes up, it also creates select, which is predefined up here as an integer, which is how you create a temporary listen. Select listens on channel 99 for whatever info will come its way. Triggers the listen. If message equals lockup, gives you the instant message, sit on elevator for transport to police lockup. There that is right there. I will deal with this part in just a moment. Target position equals lockup. We established back here vector target position. Again, a global variable, so it can be called by any of these functions, and it can hold information between functions. So we get up here, and it's just like the set teleports before. It detects the key, making sure there's an avatar on it. This is just a way to make sure that that is the correct change, is that an avatar sat on it. It automatically says to the sitting avatar, please select a floor first. I really should go through and code this to filter that so it only gives this message if you haven't selected a floor, but it doesn't interfere with the function, so it hasn't been a high priority to fix. Set region position, target position. Again, global variable. Set during the listen here. That's how it knows which floor to take you to. Unset sitting avatar. Sets its reason position back to down here. The part that gets interesting in these that I didn't mention sooner because it would distract a little bit from pointing out just how this allows you to vary the target, which is really the only significant change from our previous set teleports, is the set primitive parameters and set color. That's the other change. What that really does is that's just visual flair. That doesn't affect its ability to serve as an elevator. But if you recall how the doors open when I pick a floor, sit on it to reset it. That's what those particular bits of code actually handle. The set primitive parameters, that basically defines everything about the prim you're dealing with. Easiest way, I think, is just going to be to pull this one out. This is type box with path cut, so it's basically half of a box. We covered this in some of the early door options. You can see as I change the path cut, it changes how much of the box is actually there. And a hollow. That black line down the middle of the doors kind of helps tell that they're two separate pieces or two separate parts. That's just hollow. That's all that is. So all I'm really doing with this is changing how much hollow there is. That's the only aspect of that that's changing. I'm keeping the size, I'm keeping the path cuts. The only thing I'm changing is the hollow. The other part is the set color. Basically, the vector here is the RGB values. If you've ever dealt with any kind of computer coloring, the RGB values are going to go the red, green, and blue. And this one, the second variable, is the face. That sets it for the middle right there. If I select that face and change this, now it looks an awful lot like it does when it's open. Even the glow stays the same, because glow on black doesn't really show up like a glow. So it doesn't really do any harm to anything. So by just simply using the set primitive, you set the color to the yellow, set primitive parameters to open the hollow in the middle when it opens, and then just the reverse when it closes. That's how I got the one prim elevator doors to carry us around the police station. Much simpler than it looks when you're interacting with it. Set primitive parameters to go over how to get the right settings and how to play with it. I'll cover that in more detail in a different video, but that's all I really use for that. The next part, I'm going to go ahead and cut and then head over to where I have a map teleport set up and show you how to use that and discuss why you may want to use that over a sit teleport for some specific purposes. Here we go in a nice little tunnel, one of the understreet tunnels of my sim. What you have here, this bright shining light that looks like it reaches on past the borders of the tunnel. Just if you're curious, it's a simple mesh that has just layers of flat planes that is set to a certain color and glow, which is how it seems to get that fading effect right there. But what's important to this is you click it, and it gives you a map location. You choose teleport, and it's just as though you teleported between sims. And you walk forward out of the tunnels into a whole other part of the city. In this case, the freight yards. Don't mind the fact that I walk through this thing. I've mentioned before the advantage of setting physics. Physics none, physics convex hull, physics prim. What that basically means is this thing, it should be here for appearance purposes, but it's annoying to go around it, so I just turned off its physics. And this is the same exact prim there that I used before, but this time it's dark, so it creates a look of looming shadow going back into the tunnel. You click it, and it gives you a teleport option. I mentioned there were specific times when you'll want to use this over a set region position sit teleport, and there's a few times. One is if you want to set up links between different sims. The region position will only work within the same sim, but if you've been to particularly large regions, if you've been to the mainland, if you've been to particularly big role-playing sims, where they actually have more than one sim that is connected, region position isn't going to get you from one sim to the other, but a map teleport or a region teleport like this will. If you have permission from somebody else, I wouldn't recommend doing this otherwise. You can even set it up to transport between completely disconnected sims. You can set up, say, a advertising thing where it's like, hey, check out this other sim over here. And they click on it, and it will teleport them there. You can do that in place of giving them a landmark if you want to. And the code for it is surprisingly simple. I have to remember to unlock the object before I poke at it. The line is simply map destination. You get a particular sim, a particular arrival coordinate, and another coordinate to set what direction the target should be facing when they land. That's it. That's all there is to it. So right down here, if you bump into it, or if you click it, it just triggers port, which is just that one command. The more complicated method to do this would allow you to put a landmark in there and have it port to that, but that involves a data server call, and that is a much more complicated thing to set up. What you do to set this up is you just copy the sim name right out of the Covenant tab here, Corinthian Garden, and then you can simply drop a box down somewhere. Write a very simple script for it. You won't even need the touch start. Say, you can even leave that intact for simplicity's sake. String, to cast this as a string. Get position. So you just copy that coordinate in there, move it a little bit in the direction you want somebody to be facing, add a space anywhere just to be able to save the script again. You have another coordinate, plug that in there. Setting up a map-based or region teleport is one of the simplest ways you can get around a sim. So that covers this week's lessons. Next week, I actually have a couple of specific user requests to look into. One of them, a help with a gate design that may actually be useful to some of the rest of you, and the other one about setting up a book. So next week, it is the first episode dedicated entirely to user requests, or to audience requests. So I'll go ahead and see you next week. Enjoy Second Life. Remember, I have these uploaded by noon on Tuesdays. Keep the comments and questions coming. It really does help reassure me that this is doing some good out there. So until then, good day, good life, and happy scripting.